Welcome to the first episode of the Hackers Pod, a podcast for security enthusiasts, hackers, and everyone in the middle. I'm your host, David van Gool, and today we have Tom Tervoort on our show. Hi, Tom.
Hi, Dave. Thanks for having me.
Pleasure to have you. So, Tom, you are a full-time pen tester, vulnerability researcher, and also the discoverer of the Zerologon vulnerability. So I'm really curious to know a little bit about your story, what got you into pen testing, where you are today. So why don't we start with that? How did you get into pen testing and vulnerability research?
Yeah, so originally I wasn't somebody like a lot of my hacker colleagues who started hacking stuff in elementary school. I did not hack the school system or anything like that, or wasn't really that familiar with the world in the first place. Although I was pretty interested in technical stuff, anything kind of related to computer science. And when I went to college, I actually kind of had a vague idea of becoming a game developer. That was the topic that interested me in the time. Although I quickly found out that while I do find game design very interesting, like the more softer side of it, actual games programming, stuff related to physics, graphics, and so on, didn't really interest me at all. And in college, I did figure out that I found software engineering quite interesting. Got like a side job as a programmer, and actually ended up working as a software developer for quite some time. And while I was doing that, I eventually realized I found it very interesting, but it was also not entirely the right thing for me. And something that I kind of stumbled upon and started focusing more on was security side, more from the software development, defender kind of perspective, but then slowly also doing some offensive stuff. And I have particularly cryptography I thought was very interesting and cool. And then I broadened it a bit to more security in general. And eventually I applied for a job as a pen tester. And now I've been doing that for 5 years. So, yeah.
Nice. And what got you into cryptography? Because it's not typically a subject that off the get-go from software developer to studying cryptography is the most common jump per se.
Yeah, and I think it was basically just an university course and then slowly having to apply it a little bit in practice. And I've never really, I've followed bits and pieces of cryptography master courses, but I'm not a cryptographer or an expert. More of a cryptographer hobbyist, you could say. I never. I built some toy things, but I did eventually learn enough about it to know that I probably shouldn't start building complex cryptographic systems myself or putting important cryptographic stuff in my software. Because when you start realizing how much can go wrong there, you do know, like, oh, maybe I'm not yet qualified for this. But yeah, I really like reading Bruce Schneier books, blog posts from Matthew Green, who wrote a lot about cryptographic attacks in practice. And I started really getting into when these, for example, these vulnerabilities in the TLS protocol were big news. I found it very interesting to see how that would actually work and how do you actually, okay, we have some crypto bug somewhere. How do you actually turn that into something useful? And then, of course, when working as a pen tester, you do actually encounter a lot of weird crypto, even when you're testing like web applications or stuff like that, or custom software. Even people do a lot with cryptography, and even though it's like not what you traditionally call rolling your own crypto, people do use it a lot, and also some pretty low-level stuff. And I always found it pretty fun to poke at that sort of stuff and trying to turn that, not just to find to say oh, you're using SHA-1 instead of SHA-2 and that's bad because the number is not correct or something, but actually trying to see, okay, we know this is probably not best practice, but can I actually exploit this? Can I find some practical way to turn this into a real working exploit?
Yeah, I got a lot of questions about that, right? Because for me, crypto, you need to have a very, I guess, mathematical background, right? Because, you see online, I've read some of those TLS blogs and stuff, and it's, all these diagrams and maths and moduluses and such. Do you need to be very well-versed in math to be able to perform certain crypto attacks or understand how crypto works as a whole?
Some basics. You don't really need to have a math background. I don't really have an in-depth math background. Actually, I learned about a lot of mathematical concepts through cryptography.
Oh, really?
So,
Okay.
and I probably, when you go a little bit more in the abstract, if you look what actual mathematicians are doing, it goes way above my head. But I do think actually a lot of the crypto attacks that I actually do in practice, a lot of the practical testing usually just involves symmetric cryptography. And then you basically have to know how XOR works and how you can creatively puzzle some things together. But it doesn't really involve much math at all in practice. And interestingly enough, a lot of the practical crypto bugs what that I see in applications have a lot more to do with symmetric crypto and not necessarily the asymmetric part, because that's usually the part where people think, oh, I don't want to touch this, I don't want to implement this myself. I use a library that takes care of this. Of course, there's still some ways that can go wrong. Mm-hmm. And there's also a whole class of crypto bugs that people don't really talk that much about, that don't really have to do much with whatever cipher you're using yourself, but more the way you use it. So let's say you have some kind of magic crypto box that does some, that you put in some bytes and then the result is encrypted in whatever way. And let's assume you can't mess with it in any way whatsoever. If you can trick a piece of software, if it uses the same type of cryptographic mechanism, the same key, but it applies that to different types of byte sequences. Something you can do quite often is trick it to encrypt one thing and then use it against the other thing. So let's say the application, this is actually something I found during a pen test. It would encrypt two things. One is a sensitive value you're not supposed to read. Mm-hmm. And the other one is actually a value that you can control. Like, let's say your last search term in a web application. And the other thing is the secret. But it also encrypts the last search term because it just encrypts everything. Well, then you can search for, you can swap these two values around. And suddenly the application is showing your last search term was secret. So really simple things like that, basically just swapping stuff around, can be surprisingly effective. And you don't really need to know anything about how your crypto black box works in practice.
Yeah, and so what tools would you use? I imagine, right, in this example, you use something like burp, right? And then you can modify the values that way.
Well, when you're testing a web app or anything over HTTP, burp is incredibly convenient. Of course, you... especially the part where you can automate things, where you can you have like a long sequence of bytes and you can just twiddle with stuff. But in practice, most of the time, it's really hard to find these kinds of bugs blind. Mm-hmm. There are cases when you can, but usually you kind of need to have source code.
Okay.
I mean, at least otherwise it's a lot of speculation usually, and a much more difficult puzzle. Can also be interesting. And with some of these examples of if you see stuff that looks like cryptographic and you swap it around, you can maybe find that as well with some experimentation. But a lot of the times, like the major crypto bugs I found, I did with source code, or not with source code, but with some kind of document that described how the crypto works, or protocol specification. And then you just do basically pen and paper, draw out the thing in theory. And first try to come up with it completely theoretically. So don't actually talk to any applications, but do the back of the envelope math. It's not really math. It's more like seeing what can work, what cannot work. A lot of exploring the code. You find a crypto bug somewhere, but you have to know where the input comes from. And you have to go back and back to the code and see, can I control this? Can I influence that? Trying to come up with an attack scenario, trying to figure out how the code is used in practice.
Understood.
And then go to exploitation. And then you figure out that your analysis of the code was wrong when you're actually doing exploitation and you have to tweak everything to finally make it work. And it's very fiddly. And something very frustrating that happens a lot is that you see terrible crypto, huge mistakes, but due to pure coincidences, it just happens to be unexploitable.
Okay.
And that happens a lot.
So it's not so much as like a brute, you don't necessarily brute force crypto. In order to find the crypto vulnerability, you have access to the source code, you go through it. And so how would that work? Do you per se take the crypto function or the stack trace of functions and create your own app and then control the input that way? Or how do you play with the function to find that vulnerability in the source code?
So basically, usually you kind of start with, when you look at the code base, you basically look where they do interesting crypto stuff. And do they use some, there's like a number of common bad practices. And at the very first, you see, do they use one of these bad practices and try to understand how it actually works, what they're doing. I guess that's step one. Try to figure out what kind of crypto they are doing and try to find out what the purpose is, because it's also very common that people add what I call just crypto sauce to something to make it magically more secure when it serves no purpose. Or maybe it serves a purpose like the requirement says, oh, we need to do encryption at rest, which I actually think is a horrible instruction because it doesn't tell you anything useful, because what does it even mean? So they're like, oh, we encrypt this and we put the key right next to it, and now we have encrypted something. And then actually the purpose of the cryptography is kind of useless, but it doesn't really achieve any useful security goals anyway. Or even when the crypto is secure, you can think, well, even if it wouldn't be, they don't really achieve any security goals. It's basically like some meaningless, we need to encrypt something, let's do some encryption, but there's not really a scenario where an attacker can really get to the encrypted stuff anyway, so it doesn't add much value. So, and that happens a lot, that you find crypto stuff, especially when we do like source code assessments or like pen tests where you have access to source codes. You see crypto stuff, but this is not really interesting. This doesn't do anything useful. Yeah.
And how often do developers then roll their own crypto, right? Because in my head, if I'm a software developer, I use a crypto library that comes with whichever framework, but it sounds like that's not as commonly used, and they adapt it some way, or they don't use it the way it's intended.
So the really tricky thing is, of course, you can say to people, don't roll your own crypto. Then there's still problems with that. First of all, when are you actually rolling crypto? Is it when you're making your own block cipher? Is it when you're implementing something low level, high level? What's low level, high level? Is using TLS, rolling your own crypto. And the second problem is crypto can sometimes be incredibly useful. There are really some things you can solve. Now, I would generally say whenever you design something, try to solve it without cryptography. In 9 out of 10 cases, you are not going to need cryptographic tokens in your web app. Just use some random string that points to your database that has much better security properties in general, and you don't need to. You're not operating at massive Facebook scale, so you don't really need those crypto tokens. But in many cases, you can achieve some really useful goal with that cryptography. And then a big problem is when you actually want to build something. A lot of the standard libraries, especially those that come with programming languages, are absolute garbage. As in, they give you extremely low-level building blocks that are extremely difficult to use in a secure manner when you're not like a professional cryptographer yourself. Like, in my opinion, you should never use hash functions directly. When the AES appears in your code, that's too low level. You don't want to deal with these kinds of low level design primitives. You want to have something like something that works a little bit better. Is there's like there's a library called Lipsodium based on the Salt library. That's ported to a lot of programming language, and there it just has something called CryptoBox. And you give it like a public key and a private key, and it makes a CryptoBox that is protected against tampering and this and that. And even there, it's still, even these kinds of sort of, let's call them like medium level cryptographic building blocks, there's still a lot of ways you can use them incorrectly. Like what I just mentioned, something that's really common is that that's swapping of the ciphertext, swapping of the encrypted values. That's something that you really need to account. How are you using this? Also, how are you going? You need to manage secrets. You need to manage keys. How are you going to do that? How are you actually going to achieve a useful goal? And that's still like building more high-level designs is tricky. And it's kind of difficult. But a good start is to just don't use like Java standard or .NET, C# standard libraries, where basically anything where you have to think about padding schemes, or do I use CBC or CTR? Whenever you have to think about that, it's too low level. It's avoid these libraries. They usually cause a lot of trouble.
Yeah. I like the word you used earlier, like the black box. That's kind of how I see crypto, right? And if it's just you plug it in and it works, it sounds fantastic.
Yeah, and I think at first when you think we are going to need cryptography to solve our problem, well, first consider, do you really need cryptography? Is there a more traditional solution where you don't have to worry about keeping secrets, where you don't have to worry about cryptographic mistakes? Try to really clearly formulate an attacker model. Okay, This is what we do not want an attacker to be able to do under these conditions. Because a lot of times I see, we are worried about some security issues, so we did some crypto here, we added some crypto sauce, and now it's more secure. Mm-hmm. That doesn't mean anything. So, like, encryption at rest by itself is a meaningless term. What are you trying to defend against? Are you trying to defend against somebody physically taking a disk out of your data center and being able to recover the data from that? Well, then there's disk encryption-based solutions. But even then you think, okay, but what are we going to use to actually encrypt those disks? And how do we use that in practice? Are we going to have somebody go into our server room and enter a password every single time? Yeah. So you really want to try to see, what are we trying to achieve? Can we use really standard protocols, high-level stuff for this? Like when you want to encrypt stuff in transit, we've got protocols like TLS that are pretty standardized, but even then, when you have more complicated use cases, maybe certificates on both sides, you also really have to think about how you're going to implement that. But yeah, first of all, try to see what problem are we trying to solve. Can we do this without cryptography? And if so, what are really the properties that our cryptographic scheme needs to have? What should be possible? What should not be possible? Because that's also something you could get tested. You could maybe invite an expert over and say, well, we have used this, we have built this, it has these properties, it's supposed to protect against this. Can you check how this works? Mm-hmm. And also, sometimes there can be some difficult issues here. Like, for example, say you have cryptographic keys. It's probably pretty obvious you have to keep them secret. But yeah, what happens when you lose those keys? Have you got some means of recovery? What happens when somebody learns the secret keys anyway? Have you some way to revoke these keys or replace those keys? And these are some pretty tricky high-level architectural questions. And that's probably something you should think about before starting to throw crypto at the problem, trying to solve it.
Yeah, it sounds like in a lot of these use cases you're describing, it's a developers who are just told, here's a checkbox kind of thing, you need to use crypto for this, and then use some kind of library and then hope it works. And look, it works, and then move on. But really, they're introducing some kind of security vulnerability into their code base.
On the other hand, one advantage that you have when you use crypto stuff is that in general, you do need some specialized knowledge to also attack these kinds of systems. So if you have a specific web app, I already mentioned that it's really hard to attack these kinds of systems where you don't have source code. I would say sometimes the impact of crypto attacks can be really large, especially when these cryptography deals with authentication. Instead of, a lot of people think cryptography that's used to hide information, but probably a far more important application area is authentication or protecting stuff against tampering. Generally, that's far more scary stuff. If you get that wrong, you have a much bigger issue than, oh no, somebody who's snooping my network and maybe sees things. But then again, it's really difficult to attack these things. Most script kiddies probably are not cryptographic experts. Also, in general, it's kind of, the same holds for pen testers, which is kind of a negative downside. It's really hard to test, is this cryptographic scheme actually secure in practice? Mm-hmm. Because it's easy to tick off boxes, SHA-1 is bad, SHA-2 is good, but actually figuring out if something has a crypto vulnerability, that's something I don't really know the right solution for yet, how we can make more standardized methodologies so you can test crypto stuff without really being like a specialized expert. That's like really like a crypto hobbyist like myself or like a more professional cryptographer. How can you have people who have more surface level knowledge, give them like the tools to actually say something more about the security of some cryptographic scheme? Yeah, no,
understood. Now, another question I want to ask, because you were kind of mentioning there, sometimes you don't have the source code and you can actually find crypto vulnerabilities through documentation. How does that work? Do vendors publish exactly how they write the crypto? How do you find that in the documentation and find a potential crypto vulnerability?
Yeah. So Zerologon is a good example for this because Windows is not open source, but their protocols, or more Active Directory related protocols, have public specification. Because if you want to have software that's implemented by different vendors and they should be able to talk to each other, you need a protocol and you need a protocol specification. And a specification is usually just a blob of text, English language text that tries to describe how systems should behave. And when a protocol involves cryptography, well, you have to write down how this cryptography works. So then you can start looking for protocol flaws. And there it really is. It starts out. That's basically how I discovered the underlying vulnerability for Zerologon. Actually, I was looking for something completely different, more in the area of the typical crypto bug. You're sitting in between two systems, man in the middle, and you're trying to change things while you're between two parties that are talking to each other. But then I realized the authentication logic, where how you prove that you are who you say you are. In this case, it was based on passwords, but you don't actually want to send the password over the line because then people can see the password. So you use some cryptography on your password to prove that you know your password. Mm-hmm. And it turns out, basically, fully on like a pen and paper exercise, I could come up with a way and was like, hey, wait a second. If I do this in this particular scenario, I can give this cryptographic proof that I know my password without actually knowing what the password is. But the proof will still be correct. And then you start working from that, and I made like a whole theoretical, like sort of like half of a theoretical attack. I was not entirely sure how to exploit this because there were, I think I could probably, the first step should work, but then, yeah, okay. Mm-hmm. Now what do you do after that? Can you do something interesting? Well, I had all kinds of theories, but there were a lot of things I was not sure about because protocol specifications are pretty ambiguous. And I was thinking, well, maybe this could work, but I have no idea if they actually implement it this way. Because when you're doing crypto attacks, you're usually really looking at the weird edge cases of the protocol. So, for example, in this case, in the case of Zerologon, there was like a timestamp that you had to encrypt with a key that's in this scenario you would not know. But you could choose the timestamp yourself. And then I was thinking, well, technically, if I could have a timestamp that has the value 0, which corresponds with like January 1st, 1970, and I can encrypt, it will encrypt to a 0. So if I put in timestamp 0, encrypted timestamp 0, it should theoretically match. But is the server actually going to check if this timestamp is, somewhere in the last half century? Does it actually allow the value 0? A next step of the attack would involve setting a password or messing with a password. And I was thinking, I had all these complicated ideas of how I could change a password, but I also had to encrypt the password without knowing the key. And the very most simple attack that I could think of was, just put all zeros there and I have a 0-length password. And I was also already immediately thinking, that's never going to work. I mean, that will be my starting point, but then I'm going to have to twiggle these bits, so maybe I can come up with like just enough characters to get under the minimum. And then I know what these characters are, and these are kind of guessable. So I was... So basically, I was kind of at the point where I knew like the theoretical flaw. I knew like the first steps of my attack in theory. Didn't know if they would work in practice. And I had a vague idea what my follow-up steps would be. So then I started basically just implementing something that would talk this protocol and then run it against an actual implementation, a Windows virtual domain controller in a virtual machine. And then I did like the first steps. And then I kind of had like the first half of the attack set up. And then I had most of the complicated code ready, and then I was just messing around a lot and seeing what was possible, what was not possible. It turned out a lot more was possible than I thought. And basically kind of experimentally, I came to the full exploit. And a lot of potential caveats that I thought, this is never going to work. It will never accept this in practice. Turned out to actually totally work. And eventually I came up with like a whole attack where I could just run the final command. And suddenly I was looking at like a dump of all the password hashes that were stored inside and thinking, I think I'm a domain admin now. So it was kind of, it's a bit of an iterative process, but it really started with just purely the purely theoretical part where you only have this PDF. And I really spent a lot of time like searching through this PDF, Control-Fing two things, writing stuff out, making a lot of mistakes there. I thought, I can maybe do this. And then it turns out I was wrong. Mm-hmm. But you more carefully read another section of the PDF. But it really started out as like a big theoretical exercise. And only then I went to the the hacking part, actually throwing stuff at the server in practice. And then adapting like my proof of concept code until it did something useful.
Yeah, I find that really cool. And I guess I also never would have guessed like a crypto flaw could actually get you, domain admin on a Windows server.
Yeah.
So I guess my big question is, it sounds cool. I want to get into crypto, understand more how it works, right? It's because it's still for me a big black box. How would you suggest that I start learning more about crypto?
That's a good question. Something I didn't really. That's probably something I could have prepared. To give some good pointers on. I want to start at crypto. I think there are the Crypto Pals challenges by a university. I forgot what it was because I did not actually. That I think might be a really good start. If you just Google Crypto Pals, it basically introduces both a lot of basics of encryption schemes, how they work, and also how they can attack it. It's basically really focused on abusing crypto flaws. I think that's a really nice start. Maybe a good book. It's Cryptography Engineering by Bruce Schneier and two others, who I also don't know from the top of my head. It's probably not incredibly up to date, but it talks about a lot of the principles really from a practical application standpoint, and then just reading up on crypto flaws and see how they work. So if there's big things published, like Zerologon, for example, but when you look back to other cryptographic vulnerabilities, some really ones that I really like are, for example, the stuff that David van Gool does with the Wi-Fi security protocols with WPA2. He has found a lot of very interesting vulnerabilities related to Wi-Fi security, and there are some really cool practical crypto bugs behind this that are really interesting how they go from like a theoretical shortcoming to like a practical, really executable attack and actually getting that to work. So I think those are some examples I personally like. And of course, before you start with attacking crypto, maybe it's good to kind of know the basics of how it actually works and follow maybe some like an introductory course. Particularly on the symmetric stuff and the how the asymmetric stuff like works in principle. You don't really to be able to test crypto systems or attack crypto systems. You don't really need to know how elliptic curves work, but you kind of need to know how. You might want to know how to use them, or just like general principles of public key cryptography, what a signature is, how asymmetric encryption work, how protocols like TLS work. And maybe another good thing to realize is that cryptography is used a lot for authentication, for proving integrity. And that's encryption and authentication are not necessarily the same thing. Like one of the most crypto flaws I see everywhere is that people use a scheme that is designed to hide information, to purely do encryption, but they don't apply any authentication or integrity protection. Well, that's actually a thing they should really have on, because for example, they have an authentication token that says what your username is. It's not that interesting if people know what your username is that have your authentication token, but it is very interesting if people can change the username in the authentication token. So that's also probably where the more interesting high-impact vulnerabilities lie.
Oh, perfect. Yeah. Well, Tom, I'm going to have to thank you for being on our show today. It was a pleasure. I personally learned a lot. So thank you very, very much. And that concludes our first episode of the Hackers Pod.
Okay, thank you very much. It was fun to do.